Lesson 7.8 is on inverse functions and inverse relations. So if we're just looking for inverses, recall that a relation is a set of ordered pairs, which means that the inverse relation is the set of ordered pairs obtained by reversing the coordinates of each original ordered pair. So essentially, the trick is always switch x and y. If you just switch your x and your y around, that would be an inverse. So the domain of a relation becomes the range becomes the domain in the inverse. So if we have the ordered pairs 0 or 1, 3, 6, 3, 6, 0, and 1, 0. So that would be at 1, 3, 6, 3, 6, 0, 1, 0. That would be these points here. They're the coordinates of the vertices of a rectangle. So it would make this box right here. Now, if we wanted to make the inverse of this relation, that would mean then that we're looking for, instead of 1, 3, we're looking for 3, 1. Instead of looking for 6, 3, we're looking for 3, 6. Instead of looking for 6, 0, we're looking for 0, 6. And instead of looking for 1, 0, we're looking for 0, 1. That would be our new places. So at 3, 1, we'd be right here. At 3, 6, we'd be up here. 0, 6 would be here. And 0, 1 would be right here. So notice how it maintains that rectangular box that it was. But what happened to it? Well, it got flipped over this line here. We'll start right here and draw out our line. If you'll notice something special about this line is the identity, y equals x. Anytime we have an inverse, it will flip over this line, y equals x, our identity function. So anytime you have a mirror or a flip, a certain transition across that line, that would be finding the inverse function or the inverse relation. So in this case, we would say this is how the inverse relation looks. So if we want to find the inverse function, remember, the trick is always switch x and y. So if we want to find the inverse of f of x, where f of x is negative 1/2 x plus 1, well, let's, instead of calling it f of x, let's say that was y equals negative 1/2 x plus 1. So we just called f of x y. So how would this look? Well, it's a linear graph. So our y-intercept is at 1, and it goes down 1 over 2, all the way throughout. So this is going to be our original graph. It's going to look something like this. The inverse then would be if we switch them. X equals negative 1/2 y plus 1. Now it's not easy to graph it when it's x equals something, so let's switch it back over to y equals something. So let's subtract 1 from both sides, and we'll get x minus 1 equals negative 1/2 y. And it's still not easy to get something we want y to be all on its own. So to get that negative 1/2 y out of there, remember, anytime it's a fraction, you would multiply by the reciprocal. And again, we'll keep that negative there. So we want to multiply by negative 2 over 1. Or, that's just the same as multiplying by negative 2. So we would say then that it's negative 2x, negative 2 times negative 1 is plus 2 equals y. But let's do that in blue actually. Negative 2x plus 2 equals y. That'll be our inverse relation. So that looks like this. Our y-intercept is at 2, and we go down 2 over 1, down 2 over 1 every time. So this one is going to look something like this. So that is our original in red and our inverse in blue. And notice how, yet again, those go right through our identity function, y equals x. And that y equals x creates a mirror. Those are perfect mirrors of each other going right across that line. This example down here shows the same thing. Here is our identity line, y equals x, and we have our original function, f of x, and our inverse. Now you always, a good way to know that you have an inverse is you would write f of -1, or f to the -1 of x. This little guy up here means that you're doing the inverse function. So this was your original, this was your inverse. So if we want to know whether we have inverse functions or whether we have inverse relations here, if we need to determine whether f of x, which is 3/4 x minus 6, and g of x, which is 4/3 x plus 8, if we want to know whether or not they are inverse functions, well, we could graph them and see if they are mirrored across that y equals x line, or it might be easier just to, like we did before, switch x and y on one of them and see if they match up. So let's use f of x. And we'll say y equals 3/4 x minus 6. Then we will switch them. X equals 3/4 y minus 6. Now when we solve for y, if it's the same equation as our g of x, then we'll know that they are inverses. So let's have at it. We'll add 6 to both sides. X plus 6 equals 3/4 y. To get rid of that 3/4, we'll multiply by 4/3. 4/3 x plus 4/3 times 6 equals y. And 4/3 times 6, 4 and 6 is 24. 24 divided by 3. This should actually become 24 divided by 3 is 8. So 4/3 x equals y. 4/3 x plus 8 equals y. 4/3 x plus 8 equals our g of x. So we know that they are, in fact, inverse functions. Now again, if it turned out that maybe this was like plus 18 and it didn't match up, then you would just say they are not inverse functions. But in this case, because they did turn out the same, we say beyond a shadow of a doubt, we know that they are inverse functions. And that's how inverse functions and inverse relations work.